So the first method we are going to treat is the t-test, hypothesis testing. So that's the first method we are going to treat. So now every analyst is a data doctor. The people come with their problem, they know their problem, but they don't know how to solve it. Sometimes they also know what they want, but they know the problem, they know what they want, but they don't know how to get there. So they come to you and tell you, this is the problem, this is what I want to achieve. Now, how do I get it? Now, as an analyst, you have to suggest the best appropriate statistical tool for them to use. Now, we have different tools we use in data analysis. We have t-test. In t-test, we have t-test for one sample, t-test for two samples. We have ANOVA. We have regression, linear regression. We have time series. We have MANOVA, logistic regression. We have different tools that can be used in statistics. Now, the main thing is for you to master all I've taught so far. Once you know all I've taught so far, there is no challenge. So any other thing you want to learn, let me just show you how to get it. For example, if I want to learn codes for, let's say I want to see the codes for ANOVA, what will I do? I will do ANOVA, arrow codes for ANOVA. Since you've understood all I've taught so far, you can get any code and replicate it, arrow codes for ANOVA. So you search online, just look for it. So look at the code, just one line. That's it. If you want to do pairwise test, just one line. Very simple. This is another, just one line. So very simple. You can also click any of these. So if you want to do arrow code for linear regression, I can click linear regression. So far I've taught you all the major things I think you should know in so linear. So you can click this. Just look for any of them and click. For most times, if you want to see, let me click this arrow statistics, open another tab. So linear regression. So this how to do your plot. This how to do your plot. This box plot, which I've taught you per MF. I've taught you box plot. I've taught you box plot. So you should be able to interpret. I've taught you this. I've taught you this. I've taught you this. Now this depends. So this is just a code to plot this. Just one line. Just one line. Now you should be able to understand what this is. What is this? They are trying to the data is scarce. The data is scarce, and in cars they are trying to select a particular variable, VIST. They are choosing a color red. Now they want the density. The density is what gives them this. Then the polygon, plot it as a polygon. No, this for this. I think this one is density. Okay, density, yes. Plot, polygon, correlation. This is just one code for correlation, one code. So you should be able to understand what this is. You should also be able to understand what this is. Now, if you want to learn about correlation, COR, what do? You use question mark, COR, question mark, COR to learn about. So you just go to your arrow, so you do question mark to learn more about COR. So that's why I focus on teaching you the basics, so that when you master the basics, you already know almost everything. Because we have different functions, different codes in R. So you can't learn all in 1 year. Yeah, you keep on learning because, like I said, in R programming, you can create code and save. So they have different methods in statistics. So if you know the basics, you can write any code for any method. So you read about correlation, what COR means, how to write the code. Very simple. So now any code you want to get from henceforth, you can go online and get the code because you know the basics. You should be able to replicate the code. So this is the code for the linear model, just one line, just one line. Then you also learn how to interpret it. You also learn how to interpret it. So we've done all the major work here. Major work here. So now it's for practice. Take note that how to write function is very, very important. You have to practice that and master it, how to write function. So different codes, just learn different codes you want to learn. So if you want to do for ARIMA, you search ARIMA. That's how to do any code you want to do, you want to write. So I've taught you the basics and you should be able to interpret codes now and replicate it. So try to master all we've learned so far. So we'll just create few methods and we'll end the class. Just create few methods. Then we'll end the class. So let's start with t-test. So when do we use t-test? Like I said, you need to know the right tool to use and to recommend. Now we use t-test. Now in t-test we have one sample and two samples. T-test, one sample, two samples. So let's start with one sample. Now if let's say an investigator is making a claim. When we talk about hypothesis testing now, we have a claim that we are trying to verify whether it is true or not. So we are trying to verify a claim whether it is true or not. So an investigator is making a claim, or a producer is making a claim, or a statistician is making a claim, or a government official is making a claim about, the VC can make a claim that the average age of students in a school is 22 years. So that's a claim. Now you have to verify that claim, whether the claim is true. Now, because we have only one sample in this example I gave, what's the sample? Student. That's one sample. So because we only have one sample, we use one sample t-test. Now, I'm trying to avoid going deep into statistics. Now, in statistics, we have, okay, let me just limit myself to just t-test. So I don't want to go deep into statistics because we are not learning statistics here. So whenever you have one population and you have a hypothesized value, and you're trying to test if that claim is correct or not, you use one sample to test. Now, let me give you another example. Let's say I have a company producing bulbs, electric bulbs. I can make a claim that the average lifespan of my bulb, the bulb produced in my company, is 100 days. Now that's a claim. I can make a false claim just to sell my product. Now they may call a statistician to verify that claim. Come and verify if what this man is saying is true before we can approve the goods he wants to start selling. This can also be done to medicine or different things. So let's continue with the example of the electric bulb. So I started producing electric bulbs and I'm making a claim that the average is 100 days. So assuming in the country they have a limit that no bulb produced in this country should have a lifespan less than 90. So because of that, that's why the producer is trying to make a claim that his zone is 100. So now they'll have to call you to verify if what he's saying is actually true or not. So now we have one sample, the bulbs produced, and we have a hypothesized value. What's the hypothesized value? That's what he's saying, that is up to 100 days. Now, whenever you have one population, one sample, and a hypothesized value, use one sample t-test, one sample t-test. So now, mostly I'll be simulating data for what I'll be doing. I'll be simulating data for the test that I'll be doing from henceforth. So now let me simulate data for this company. So let me call it Bob's. So let me use the uniform distribution to simulate it. Now let me simulate 25 bulbs. So now whenever you want to verify a claim, what do you do? If this is a real life experiment that you want to conduct, what you do is you collect samples from we're using our example from the bulbs produced. Now, first you have to ensure that the sample is a true representation of the population. The sample is a true representation of the population. You don't have to be biased. So now you have different methods of selecting sample. We have the simple random sampling, systematic sampling, stratified sampling, but that's not what we are learning now. So but just you have to collect a sample and you must use the right method of sample collection. And the sample you are collecting must be a true representation of the population. So after collecting the sample, you can cut the test to know, maybe you can give the bulbs to different people to use and record the average lifespan. So after recording the average lifespan, you will use the values they will report for the 25 bulbs you randomly selected to carry out the experiment to verify if the bulbs produced by the company is equivalent to 100, if the lifespan is equivalent to 100 days. So now I want to simulate 25 data. So the lowest value I want should be 60, and the highest I want should be 110. So that's what I'm doing. So let me see the values I simulated. Remember, uniform is a continuous. So let me round it. Let me round it so that I'll get whole numbers. So round 0. 0 means whole numbers. I just finished rounding. So let me see what I have in box. Box. Correct. So wow, box. So this is wow, 25. Now, let me explain what this 1 here and this 19 means. This 19 means this place, this is the 19th number. So yeah, that means 1. This first row has 1 to 18. Then is the 19th number. So 19, 20, 21, 20, 23, 24, 25. So it's just to keep track of the numbers. Now, since I have my data now, so these are lifespans of bulbs produced by the company. So I want to test the one sample t-test. Now, what's the code for one sample t-test? I'm trying my best to avoid going deep into statistics. Because most of the people in this class are not, they didn't do statistics in school. That doesn't mean they cannot do data analysis. It's possible they can still do data analysis. So that I'm trying not to go too deep. So I'm trying to explain it in a way that everyone can understand. So the code to use for t-test is, now let's learn about t-test before we continue. So use your question mark t.test. So look at it. Look at it, performs 1 and 2 sample t-tests on vector of data. So that's it. So you know what you mean. So let's continue. So the code is t.test. Then you write the data that you are carrying, the sample that you collected. Our sample now is bulbs. Now then you state the hypothesized value. You state the hypothesized value. You state that, take note, the hypothesized value. So we use mu to state the hypothesized value. What's the claim is making? So now the claim is making is that the hypothesized value, the average lifespan is 100. So that's the claim the bulb producer is making. So that we want to carry out the test. So we can run this test. Correct. So these are results. Now, how do you interpret the results? Look at the arrow told us that alternative hypothesis. The alternative hypothesis there is what? The mean is not equal to 100. What's the null hypothesis? The null hypothesis is that the mean is equal to 100. So now you have to interpret your results. Maybe I can copy this first. Now you want to take notes. You don't just copy your result the way arrow gives. You have to arrange your work. No. You have to arrange your work the way you want. You have to arrange your work the way you want. Now I will delete this later. I just want to see the results. I will delete it later. So now let me start interpreting. So you state, now there are different ways of interpreting it, different ways, different arrangements. So I can decide to write it in words, in statements. You can decide to write it mathematically or statistically. So I can state like this: the null hypothesis, for this test, you must not follow me, is that the average lifespan of the bulbs is 100, and this is tested against the alternative. Remember, you must not follow me. Just arrange your work the way you want and the way that anyone that looks at it will understand. Tested against the alternative hypothesis that the average lifespan is different from 100. Now, then the next thing, take note of the step. The first step in testing hypothesis to state your null hypothesis. Second step is to state the alternative hypothesis. The next step is to state the level of significance you'll be using. Now, I want to talk about level of significance. We're talking about the probability of making type 1 error. Still trying to avoid going deep, but just know that it's the allowance we are making for error. So we are trying to make an allowance for error. So the allowance we are making is the level of significance, the probability of committing type 1 error. There is no specific rule I can say, but there is a rule of thumb I was taught. So whenever you are working on live data that has to do with life, that you can use the level of significance you should use should be very small. But if you are not working on live data, you can use, it should also still be small, but you can still give more allowance for errors. So that because we are not God, we are trying to estimate, we are trying to carry out analysis to get an estimate of the true value. So there's a possibility that you may not get the exact value, but your value should be close to the true value. So there should be allowance for error. So when talking about live data, like I said, it's not a stated rule, just like a rule of thumb. We are advised to use 0.01, but when you're not working with live data, you can use 0.05 or 0.10. So for this work, we're going to use 0.05, which is mostly used. So the level of significance used for this test is 0.05 full stop. Now, what I've written so far, another person may decide not to do it this way. Another person may decide to do it like this. The hypothesis for this test are given below. The person may decide to write it as this H naught. Now, I would have used the math equation, but I don't have math equation in this. My words, I need to go and change this word I have. So I don't have, that's why I'm using this to type. That's why I'm using this. I'm not supposed to use this. I use math equation to type anything like this. So I can write H naught as this. The average lifespan of orb is this. So this is how another person may write it. Another person may, I'm showing another way to do this. H1 then alternative hypothesis different, then they will say the level of significance under insert symbol alpha. So alpha is used to represent level of significance. I can go back to this place and return it back to my alpha. I didn't ask you to change it. Correct. Now both of them are the same. Now you can decide to write your interpretation this way. You can decide to write it this way. So depending on your choice. Now the first step, take note, first step, you state your null hypothesis. Next, you state your alternative hypothesis. Next, you state your level of significance. Level of significance. Then you state your test statistic. After stating your test statistic, you have to state the reason why you are using it. So I'm stating my test statistic now. So the one sample, t-test. For subsequent analysis, I'm not going to explain it this way. I will just say it verbally, just say, tell you guys the interpretation. I will not be typing the way I'm doing now. So after this, I don't think I'll be typing again. So what I'll be doing is just to tell you how to interpret it. Try my best to explain it, then you'll be the one to type it when you want to do your analysis. So the one sample t-test will be used for this study. Then you state the reason why we are using it, since we have one population or one sample with a hypothesized value. Okay, let me explain something now. I'll be trying my best to avoid going deep into statistics. So let's just stop here with the hypothesized value. Now I've stated the test statistic means the method, the formula, tool that I'll be using to test my hypothesis, whether to reject or not to reject. So the tool I'll be using now, like I said, you are a data analyst, data doctor, so you really want to recommend the best tool to use. For this work, we're going to use one sample test. That's the best tool for this work, for this particular problem, to know whether the claim the company is making is actually true or not. So we use for this study, and the reason is because we have one sample with the hypothesized value. Now, for you to use t-test, normally the population, the data is supposed to be from a population that is normally distributed. That's one. Then after stating the next, you state your decision. Now, remember, you can, if you are, remember, I'm showing you two ways of writing it. This is, we have different ways of writing it. Must not just these two ways. So I can write it this way, or any other way you choose to write it. Then after stating the test statistic, I can state the value now. So the t-test, the t calculated value is, look at the t calculated value. Are you seeing it? Look at it here. I got it from my arrow. Then I will write the probability also. So let me copy it. And the p-value of the t calculated value is, this is just like 0.0. Full stop. Now the next thing you state is your decision rule. Now you state your decision rule. We reject this whenever you're using. So most times now we can, in making my decision, I can use the t-test or I use my p-value. Most times we'll be using, or if not always, we're using the p-value. Why? Because for you to use the t-test value, you have to be with your statistical table. Now, most times it's difficult to be with your statistical table always. So that's why we use the p-value to make our decision. Computer has made it easy that we can use p-value to make our decision. So we reject the null hypothesis, or you can say we reject H naught. So we reject the null hypothesis if the p-value is less than, you can either spell the less than or write the symbol less than the level of significance. So you can either see the level of significance or you write alpha. Remember our level of significance for this, we selected 0.05. We are free to select any level of significance. Take note of all the steps. First step, null hypothesis. Next, alternative hypothesis, level of significance, the test statistic, decision rule. Then what's your decision? So now compare it. Look at the p-value. The p-value is this 0.00. Is it less than the level of significance? Yes, it is less than. So whenever it is less than, we reject. Then assuming it was greater than, you will not reject. Take note of the word we use in statistics. We don't use the word accept. We don't say we reject a hypothesis or we do not reject a hypothesis. Now, why don't we use the word accept? Now, remember, the claim is already assumed to be true. The company is already making a claim and they're assuming the claim to be true. Now, they paid you to check if it's false. So if you, based on your analysis, you were able to find out reasons to reject it, you tell them, I was able to find out reasons to reject it. Assuming I could not get a good reason to reject it based on my sample, I would tell them I didn't get any reason to reject it. Now, you can't just go and conclude that what their claim is actually true because they're already claiming it is true. So your work is just to look for reasons to reject it. If you have reasons to reject it, you state, I'm rejecting it. If you don't have reasons, you state, I did not reject it. Now, you not rejecting it still doesn't mean it is true. It may be because of different reasons. One, because maybe you use the wrong statistical tool. So that's why you cannot just go and say of a truth what they are saying is correct. No, because you may have used the wrong statistical tool, or maybe your sample may not have, you didn't use the right method to select your sample. Also your sample is not a true representation of the population. So your work is just to tell them whether you the work they gave to you, whether you got enough evidence to reject it or not. They can still give it that work to one other person to look if the person will get evidence to reject it or not. Now, remember I said the initial claim is that the hypothesis is assumed to be true. So your own work is to check if it is false or not. So we'll either say we reject the hypothesis or we say we do not reject the hypothesis. Now, we reject the hypothesis. This is the reason whenever the p-value is less than alpha, and I've already stated that the p-value is not less than alpha. The p-value is less than alpha, so we are going to reject. So we make our decision. So we are going, or we reject. You put it in your own words. We reject the null hypothesis. What's the null hypothesis? Or I can just say the null hypothesis. Anybody can come back to this place and read my null hypothesis, or go back to this place and read my null hypothesis, depending on how you want it. You can decide to also write what the null hypothesis is. Yeah. Then, but when you want to make a conclusion, you tell them what and give them the reason why you are rejecting it. Since the p-value, which is 0.00, is less than my level of significance, which is 0.05. I can also decide to state this. I can state it like this. Then I can conclude that since I'm rejecting this, so I will conclude with the alternative hypothesis because I'm rejecting that. I will reject the null hypothesis since the p-value and conclude that the average lifespan of the bulb is different from 100. So based on my research, I have enough evidence to prove that what the companies claiming about their product is wrong, is false. So I have enough evidence to show them that it's false. Now they use this in most time when they want to test it for different things. A claim made by an individual about a particular product, a particular sample. We have one sample, we have a hypothesized value. So when we have one sample and we have a hypothesized value, what do we use? We use one sample t-test. We use one sample t-test. Take note of that. When you have one population, one sample, and a hypothesized value, we use one sample t-test. So now let's go over to the next thing. The next thing we're going to talk about is two sample t-tests. Now, when do we use two sample t-tests? When you want to compare. So let's say we have an existing company. Remember, I said I will not be doing most of this interpretation again. Take note. Now, I'm going to delete all this. The thing I need here is my t. I use this. I use my p-value. I don't really use the confidence interval. On that, you can make your decision using confidence interval. You can make your decision using confidence interval, but I didn't use confidence interval to make my decision. So after this, I will delete it. I just collected what I need from my arrow. So that's how to do this. All right, so you can save your work. Now let's go back. So when do we use two sample t-tests? Now we use it for comparison. We have a population or a sample, and we're trying to compare it with another population or sample. So let me use the education system first. The teacher came to the class and made a claim that statistics students are better than mathematics students. That's a claim he's trying to make. And one thing about in science, you don't just make statements, you have to prove it. You don't just come and make any statements. You have to prove it. Show us why you are telling us that statistics students are better than mathematics students. Now you can try to carry out the test. And because we are talking about we have two samples, two populations, we'll use two sample t-tests, two sample t-tests. We use two sample t-tests. Now, or we can also have an existing company. We can also have an existing company. Okay, before we continue, let me show you something. Back to one sample t-test. Take note of this. Now, the test I did here, we call it, we have one tail and two tail test. The test I did here is, like I've been trying to avoid going deep to statistics. The test we did here It's called two-tailed test. Now, let me explain what we mean by one-tailed test and two-tailed test, because I think you need it. In one-tailed test, the alternative hypothesis is either greater than or less than. Now, it is moving in one direction. It means we say the statistics that the critical region is in is only at one side. Either it is at the left-hand side or it is at the right-hand side. Then when it is at both sides, so it means we are talking about two-tailed test. So let me explain again. In one-tailed test, just know that the sign there is less than or greater than. It cannot be both. Either it is less than or either it is greater than. Then when we're talking about two-tailed test, the sign is not equal to, not equal to. So when you talk about not equal to, you are doing a two-tailed test. It means it can either be less than or greater than. Both of them you are considering both. Just know that it must not be that particular value. Now the test I did there is a two-tailed test. Two-tailed test. Now, assuming what I want to check is if it is less than. If I want to check is the average lifespan of the bulb is less than, not different from. Different from means not equal to. If I want to check if it is less than, how will I do it? Take note of this. Look at our F. You just write alternative, comma, because you write alternative, then you state what you want. So you can now put less. I'll run it. So this is the code for less than. What changed here is the p-value. All right. So which is still the same 0.00. Still the same 0.00. So I just told you now how to check, depending on if you're working with not equal to, less than or greater than, this is how to do it. So we'll go back to our two-tailed test. I'll go back to our two-tailed test. Now, remember I said two-tailed test is used for what? Comparison. It's used for comparison. So let's say if we have a company called Alpha Bulbs. Alpha Bulbs. They produce bulbs. They have been existing for years, for 10 years or for 50 years. Then a new company wants to start producing bulbs, and they have been saying that this is the best bulb in the country. That means they are trying to say that their bulb is better than the existing bulbs that people have been using, the Alpha bulbs. They are making a claim. And remember, you don't just go with that claim. You have to verify their claim if it is true or not. So because in this case, we have two samples, two population. We are going to use two samples to test. So we are going to use the first company, which is Alpha bulbs. Let me copy it. So we are going to use the first company, which is Alpha bulbs. Then the next company are going to use, they are producing is Beta bulbs. They are producing Beta bulbs. I can copy this. They are saying that their bulb is better than the existing one. So let's verify their claim if it is true or not. We want to verify their claim if it is true or not. So how do we do this? So we use what? No, 25 value. 25 from 60 to 160. No. From 160. Maybe use from 100 to 220. Run. So I'm simulating data for both Alpha bulbs and Beta bulbs. So let me see data is simulated for Alpha bulbs. This data is simulated for Alpha bulbs. This is data is simulated for Beta bulbs. Beta bulbs is the new company. So we are trying to test, compare them. Now also when we talk about COVID-19, they had first COVID-19 vaccine. Maybe it may have efficiency. I don't know how they call it, but it has a particular rate, number of people that were, let me use a different drug. Let's say we have malaria drug, we have an existing drug, malaria drug, and the rate of recovery. The rate of recovery can be a particular amount. That number of people that recover after 48 hours. Let's say it's 90%. 90% will recover after 48 hours. That's the record of the first drug. The second drug may come and say that they perform better than the existing drug. You can't just accept their claim and continue. You have to verify their claim. Now, you have to check if their recovery rate is the same, similar to the first, or is greater than the first, or is less than the first company. So in this case, we are talking about comparing two populations or comparing two samples. So we'll talk about two sample t-tests. So I've been trying to give different examples. Now, in two sample t-tests, we have two types. We have two types. We have the paired sample t-test, and we have the independent sample t-test. We have the paired sample t-test and independent sample t-test. Now, I will explain the difference later, but let's continue with this example. What we are solving is the independent sample. Let me continue, then later I will explain the difference between the paired sample and the independent sample. So we do t.test. The first sample here is alpha bulbs, comma. The next sample is what? Beta bulbs, comma. Then the next thing you do is to state is it paired or not. So paired, false. You can either spell the false complete or you just type F. If it is paired, you write paired true. So that's how it is. If it is false, you write paired false. If it is true, you write paired true. Then we put, it will ask, do you want, then the next thing is to select, do you want to assume equal variance or not? You want to assume equal variance or not? So I can say variance dot equal. I can select true. Now, if you don't assume equal variance, then what you'll be using is called the wedge test. When you're not assuming equal variance, what arrow will give you is the wedge test. So let me just show you. Let me not assume equal variance. Let me delete this. Let me run it. So this is what I mean. So it's the wedge two sample t-test. But if you assume equal variance, no. Let me assume equal variance. Correct. Are you seeing the difference? When you don't assume equal variance, what arrow will give you is wedge two sample t-test. When you assume equal variance, it will give you two sample t-test. Now there are if you are using SPSS to do this, SPSS will use a code to test for whether to assume equal variance or not. We call that Levene test. So we can learn about Levene test. Let me see if it is. Yeah, Levene is not test. So Levene test in arrow. To now tell you whether to assume equal. So I can click. I will open to. So the Levene test in arrow. Just look for the code. So look at the code. Levene test. Levene test. So this is the code. So the code is just Levene test. So now I've taught you this. What they are doing, read.csv, they are selecting data. I've taught you file.choose, or well, normally what we use to select our data is file import. So use import to select your file. So use import to select file. Use partlet test. That's not what we are doing. So how to compute Levene test. So this is how to do Levene test with one independent variable. So this is how to do Levene test. So it tests for homogeneity of variance. So I will show you, we'll do it also. So I'm just showing you how to get code yourself. I've taught you the basics. I've taught you all the main thing, all the things you need to. I think the major things you need to know in R, the major things. So any other analysis you want to do, just go to Google and browse the code. So look at the code. Very simple, just one line, just one line. Now you should be able to understand what this is. This is the data they are using for the analysis. Then this is where you will do something like this. When we talk about regression, I'll explain this to you. I'll explain this when we talk about regression. We are going to also do this for t-test. So for now, we'll just keep. So I've shown you how when we have two types, whether to assume equal variance or not to assume equal variance. And I've told you that what we use to assume equal variance or not is the Levene test. So now let's assume we are assuming equal variance. We'll do the Levene test later. Now you do the same, all these things I explained here. You also write all this. That the average lifespan of bulbs produced by the two companies are similar or are equal, or the average lifespan of bulbs produced by alpha bulb and beta bulb are similar. Then the alternative hypothesis would be what you want to test. Is it that you want to test that beta bulb is greater than alpha bulb? Then that's what you use as your alternative hypothesis. Or you want to test that they are not equal. If you are saying they are not equal, that means you are talking about two-tailed tests. If you are just saying that alpha bulb is better, if you are saying they are not equal, that means two tests. But if you are saying beta bulbs, they are better than alpha bulbs, then you are saying is a one-tailed test. Or if you are saying beta bulbs are less than alpha bulbs, the average lifespan, then we are still talking about one-tailed test. Just know that two-tailed test is when you're talking about not equal to, not equal to. So this is how you still interpret it. You state alternative hypothesis. You state now we are going to use two sample t-tests because we have what? We have two population and we are testing for significant difference in their averages. So that's the reason why we are using two sample t-tests. Then you state your t-value. What's the t-value? T-value here is my t-value. Then you state your p-value. My p-value is t0.00. Take note, this e, don't allow this e minus 15. This e minus 15 just take the decimal. This is just like times 10 raised to power minus 15. So this is like 3. Let me explain. That value is 3.09 times 10 raised to power minus 15. So that's what is there. That's what is there. So times 10 raised to power minus 15. Now, let me show you something. Let me round this value to, let me round it to 3 decimal places. You will see that it's 0.0, let me to 0.00. So just to your left. So that's the meaning of that. So you copy your p-value, the same thing I've explained here. Then you state a decision rule, which is the same. Then you know you make your conclusion. So very simple, very simple, very simple. Now let me show you another way of writing this code. Another way of writing this code. This is very simple. I've shown you the first way. Now another way of writing this code is to use the method we learned. What's the method? We learned how to gather your data. So let me gather this data. So first, what will I do? I'll convert it to a data frame first. So let me call the bulbs 1. Let me call it bulbs 1. I'll convert it to a data frame. Let me convert it to a data table immediately. Convert it to a data table. First of all, we'll have to call up the library. If you want to use data table, use library data.table. So let me run it. Then I will use data.table. Data.table alpha bulbs, comma, beta bulbs. So let's see what is my bulbs. Correct. So now I want to gather it. So let's see, gather. So documentation for gather. Okay, I have to call up my library. Library, I think it's DPL. I think it should be this. Let me see if gather is there now. If I call the wrong, I didn't call the right library. Let's see. We did gather. So let me see the library we need for gather. Okay. Yes, that's it now. TIDYROF. Okay, no, I use it to TY library TY or TI, correct. So this is where gather is. So what am I trying to do? I want to show you another way of doing it. You must not do the second method. I just like showing you different ways of doing it. So if you want to learn about gather, so this is how to learn about gather. So let me use it. Oh, remember when I tried type gather the first time, it didn't work because I have not called up the library. So now let me convert it to the long format. So I can call it bob2, the long format. So I'll use my code gather. Then it will ask me what do you want to gather your data first. What's the data? My data is box one, comma. Then it will ask to state the key. What's my key? The key I want to use is the company. I can use company. So we have two companies. So company is the key. Then the values. What is life? I will use lifespan as my values. Take note of, look at what I'm reading. Look at what I'm reading. I'm reading this. I'm just showing you how to try. I don't need to cram much. Or because arrow, so I'm using lifespan. You choose anything. This is a name I selected. You can use any name you want. So I can run. Let me check if I got it. So I will alight box2 and run. So this is what I did. I just converted them to a long format. What's the meaning of long format? First of all, show me all the value for alpha box. Alpha box. They should be in the same column. Are you seeing it? Alpha box. They are 25. Then on that same column, continue with beta box. So that's what I did. So I've been able to convert it from the wide format to long format. So now let me repeat the same analysis I did. So I can repeat the same analysis to t-test. Now, if you are using this, you start with. So let's go back to t-test and see something. Let's see if it's part of the app. T-test. Correct. Let's see if it's part of this. We've done this already. Okay, this is what I want now. This is the method I'm teaching you. Take note. So this is it. So you start extra now means your data, where the values are, then this the group. So in this case, my group is company. My group is company. Why my extra is like lifespan. So I will do lifespan. Then I will use this symbol. Then my group is company. It must be, remember it's case sensitive. Then I will state my data. What's my data? So this is another way of writing the code. You can decide to write it this way, or you write it the way I'm writing it. What's the data I'm using? The data I'm using is box2, the one I converted to long format. Then remember, let's copy all this other thing. Pair this false. Is an independent sample t-test. Then we're assuming variance to be true. So we can run the same result. Should be the same result. Let's see. This one, the p-value is what? 3.09. Let's see, it should be the same result. Let's see if it's the same. 09, 3.09, 3.09. So depending on what you want, you select the way. So if your data is already in the long format, you don't need to start converting it to the wide format. Just continue with the long format and get your results. Now, if your data is in the wide format, you use this method. Both of them will give you similar results. So we're going to stop here for this class. Then in next class, I will explain the difference between paired sample t-test. Okay, let's just do the event test. Back to them, we'll stop here. So look at how to do the event test. So it's the same thing with the t-test. So I will just copy from this. I will write my Levin. Okay, that means I have to use a library. There is no code for, so I have to check what the library is. Look at the library. I seen it. Look at this. You've learned what I've taught you so far is make it understand any code you want to learn. is in car package. So I know that I have to call up card. So like I told you, I told you I don't need to, the way, when you want to do any analysis and go online, they will tell you the package that you need, where the code is, where the function is. So Living test is in car libraries, which I've called up. So I can now type my Living. It's supposed to pop up now. So Living, so I have to check, is it the Living.test or the Living test? Okay, it's the Living test. The one with the uppercase T, correct. So I'll copy from this place to this place. Copy, paste, and I can run. Correct. So what's the p-value? This is the p-value. This is the p-value. Living test homogeneity of variance. So now this is, we're supposed to do this test first to know whether we have to assume equal variances or not. So let me see. There is equal variances. So let's confirm from this. As mentioned, okay. Okay, didn't state anything, yeah. But the null hypothesis is that we have equal variances. That's the null hypothesis. Why the alternative hypothesis is that look at the center, that's the meaning. Center equals to we're assuming that the null hypothesis is that they have equal variances. The alternative is that they don't have equal variances. Now, are we rejecting or not? We are rejecting. Why are we rejecting? My p-value is less than 0.05. My p-value is less than 0.05. So we are rejecting. The meaning we are rejecting the null hypothesis that states that there is homogeneity of variance. So because we are rejecting, it means I'm not supposed to assume equal variances. So I'm not supposed to assume equal variances. I'm not supposed to assume equal variances. I hope you understand this method. So I'm not supposed to assume equal variances. So you can do the living test first to know whether you are supposed to assume equal variances or not. You do the living test first to know whether you are supposed to assume equal variances or not. Remember, you always write your comments. So you can now what's the meaning of living test is to test for equality of variance, equality of variance or homogeneity of variance. They mean the same thing, equality of variance or homogeneity of variance. So you write your comments. So when you want to do two sample t-tests, you do your living test to know whether you have to assume equal variances or not. Then you know whether to assume equal variances. Then you go straight to your t-test. You know whether you will reject the null hypothesis or you do not reject the null hypothesis. Very simple. So we are going to stop here for this class. Thank you all for joining. If you have any question, you can do it to send to me.